Yes, welcome to the lab Fundamental of Physics ES 132. Today we'll be doing experiment number 3, objects in equilibrium. So I'm your instructor, SHAFIQ ANWAR, and I have already made a YouTube channel to help you guys in theory and lab both. So in theory I have already uploaded my lectures, and you can get benefit, and you can subscribe it and press the bell button to get the notification whenever I upload new, and you can like if you like and share it with your friends so that everyone should get the benefit. And yes, we will be teaching on the blackboard also, some theory classes and some lab classes also, and you have the lab manual there on the blackboard. Now, experiment number 3, objects in equilibrium. What is the objective of today's experiment is, to study the example of an object under static equilibrium and to find the magnitude of an unknown mass. If you have any object, for example, if you have this calculator or any object, you can find it, put it on the physical balance, and it will give you directly the mass. But today we'll be doing one experiment, vectors concept by the way, and objects in equilibrium. So we'll find out the unknown mass, and at the end we will put that unknown mass on the balance, and we'll find out the real or the actual mass of the object, and we'll find the difference, the percentage error in the measurement of that mass. Right. You see, the apparatus you need, all these things you have to write in the lab report also. All the apparatus, the equipment you need to complete your experiment, that comes under the heading of apparatus. Magnetic board, this is magnetic board, okay? I will show you shortly once I finish this briefing. 2 pulleys, we have 2 pulleys on each side, and you have degree scale, this is the degree scale protector. You have graduated different angles from 0 to 360 degree. You have this thread, okay? We connect all these two, this is the unknown mass in the center, and this is mass 1 and the mass 2 on the other side. Symmetric masses, these are the symmetric masses. You have graph paper, you need graph paper or simple white paper to draw the vectors and find with the graphical method. The mass holder, this one and the other one, you have the mass holder, its mass is 5 gram written, and then you have unknown mass as I told you, and you need balance to measure the real value for the mass of the object. What is the theory, the idea behind it? You see, you have done in chapter number 3, vectors and 2-dimensional motion, how you add, the 2 vectors. We will explain it in detail. So we have 3 methods: graphical method, you already did in chapter number 3, mathematical method, and analytical method, mean component method, x and y component of vectors. We will discuss in detail now. Right. Then, first of all, one by one now. The first method, graphical method. How we add 2 vectors. For example, if you have this vector, for example, A vector, or I say T1 vector, you have another vector, I say here, B vector or T2 vector, right? How to add these 2 vectors to find the resultant? What we do, we use head to tail rule, okay? This is the tail, this is the head, this is beginning, this is end. So first we do T1 as it is. You see, this is your, this is T1 here. I use the same color just for your understanding. Okay, this is same length, same direction. T1, you bring the beginning of the T2 at the end of the first, and same angle. For example, if this is its angle theta 1 and this is angle theta 2, same angle you have to make, otherwise you will be having very big error in the measurement. What we do finally, we connect this beginning up to the end like this one, right? So this will be your resultant. Okay, right. Now what we do here, in fact, in this experiment I will show you that once you hang two masses, okay, like this one, okay, you have this, for example, you see what happens when you hang some masses of the weights with the ropes and the string, it is under tension. So this is, okay, T1 and this is T2, right? Now, what is the angle it is making? Theta 1. This one, theta 2. What you do, you need to bring this one over here, right? And we select a scale. You see what happens once you have big magnitude vectors, okay? You need a scale, right? For example, if you have this vector T1, it is, for example, I say today we will be using a small gram weight. Okay, normally weight is a vector and the mass is scalar, but today we will be using we will not convert by multiplying by 9.8 to get it the weight, but we will use the term gram weight. For example, if you have T1 80 gram, T2 80 grams. Now, how to represent with the line and the arrowhead the gram weight as vector on the graph paper or on the board? We select a scale. I say okay, let 10 gram is equal to 1 centimeter on the graph paper, for example. So if you have this 80, so 80 divided by 10, you will get 8 centimeter. So what you will be doing, the same angle theta 1, whatever, for example 40 degree, you will make it with the degree scale, right? And then extend it with the ruler. How many centimeters? 8 centimeter. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Right? This is T1. And then T2, the same angle. First you draw the theta 2 angle, and then you draw the line in centimeter. I say okay. This is again, if you have the same, you may have same or different. Okay. Now, what is the method? You have to bring this over here. But as I told you, you have to make the same angle. Right? So you have to draw another horizontal line here, and with the degree scale, you have to draw the same angle. For example, I say, okay, if this is 144, you will draw with the degree scale the same angle, and then with the ruler, the same centimeter. If it is 8 centimeter, 8 centimeter, right? You may have a different, this is just an example I'm showing you, but once you do the experiment, you will be having, your own values. And then, as I told you, finally, you have to join these 2 points. This is the beginning of the first to the end of the last vector. So this is R. How much it is in centimeter, you have to measure it, and then R in centimeter first, this is the resultant, and then R in grams. How to find R in grams? first you divide it. Now, for example, I say if it is, I say 9.9 centimeter. Before you divide it to get in centimeter, now you will multiply. So 9.9 multiply by, so 99 gram you'll be having. This your value which you determine. This is, I mean, how we do. I will explain it again once I finish the briefing in the second part of the, the lecture. Right. Now, the second method, you see, once you do this one, you have to do some measurements. For example, this angle which R makes with the T1, this is called alpha, this one. And the angle between T1 and T2, this angle is theta. If you look here, from here up to here, theta 2 minus theta 1. So theta is equal to this. Okay? And alpha, you will measure it. You know how to measure it? Don't put D here or the degree scale here. You see this line and the dot point here. This point should be here. And according to, in line with this line, T1. And from here up to here, how much you will measure it and will write down in your data sheet. Right. So that was the first, method which you already did in chapter number 3, by the way. And now you'll be using, we're not going to prove this here, you will simply use this rule. What is T1, T2? You will be using the same in T1 and T2 in grams. Okay, in gram weight. Okay, and theta in degree, of course. So you'll be using the same from table 1. I will show you shortly. Okay, and then you have to find out alpha. Alpha first, as I told you in the last slide, that you have to measure by the degree scale, and here you have to calculate mathematically. Okay, you are calculating mathematically. Tan inverse T2 sine theta over T1 plus T2 cosine theta. So you have to use these rules to prove it with different method. Next method is, third method is analytical method, or component method. Okay, we call it component. Okay, now for example, if you have this T1 making angle theta 1 with the x-axis, and you have T2 making an angle theta 2 with the x-axis. Okay, now you have done in chapter 3 that whenever you have any vector A, it is making some angle theta with the x-axis. So this is x component, which is A cosine theta, and this is A y, which is A sine theta. What we do for these two, we are going to find out the resultant magnitude and its direction. So for magnitude, what you need, for example, if you have the resultant vector here, and this is the x component of resultant, this is the y component of resultant, and I give it a different name, not theta, phi. Right. Now, you see, you have to go with the Pythagoras theorem, rx square plus ry square, under the roots you will get the magnitude of resultant, right? So it means we need Rx and Ry. So for that purpose, what we do, we get x and y component of this vector and similarly this vector. For example, if I write for this one, this is T1 x, it is T1 cosine theta according to this rule, and this is y component of T1, which is T1 sine theta, like a sine theta. A instead of a, you have T1 now, right? Similarly, you'll be having T2x is equal to T2y, right? So what you do to find the x component of the resultant, you add, you know, T1x plus T2x. What is T1x? This value, T1 cosine theta 1. And T2x, T2 cosine theta 2. Similarly, to get y component of resultant, you add y component of first vector T1 and the y component of second. So T1y is this one, T1 sine theta 1, and plus T2y is this one, T2 sine theta 2. So you add them. Then of course you'll be having some number, 80 or 90 or 95 gram and theta and degree. You'll be getting some number here, some number here. So you will be using those numbers here and you will get the magnitude. So this is the magnitude of the resultant, mean unknown mass. And then phi is equal to, you see, tan phi from here, you can write is equal to Ry over Rx, which will give you, in fact, phi is equal to tan inverse Ry over Rx, right? Okay. And phi is the angle between resultant and x-axis. So this is your x-axis, positive. Okay, that's it. This is how we use the third method. Okay. Now I'm going to tell you the procedure. You see, whenever you are doing some experiment, you have to take care of some precautions, some adjustments, right? In this experiment, you see two important adjustments. This is alarming. It is alarming that if you make those two mistakes, you will be having wrong data and big error in the measurement. Okay, what are those two adjustments? First of all, you see, you have this degree scale and these two pulleys, these two masses with on the mass holder, and this is the unknown mass in the center. Now, first of all, you have to make sure, you see, this one thread, the second thread, the third. This is their junction. The junction of these three threads should be exactly at the center of this degree scale. They should coincide. This is the first adjustment. And number two is that this thread, vertical thread of the unknown mass should be exactly with the y-axis. So this is with the, it will coincide with the y-axis. So please don't forget these two adjustments. Now, what is the procedure? It's already in the manual, and before coming to the class, you will watch this video completely and will understand. Okay? Now, set up the drawing board with two freely running pulleys, as I told you, and the adjustment, I told you about the adjustment. Okay? And these two adjustments are very important. This is pulley P1, this is pulley P2, this is center of the thread, and all about. Now, the important thing is how to take the observation. First of all, your table number 1 is very important because you will be using the same data in table number 2 and 3. You will simply using those rules, but the information you will be using from table number 1. So what we do, first of all, you see what is on the one side of the we say T1 in gram weight. Okay. For example, today I'll be using, 95 gram, for example. I will show you shortly. On the second side, again 95 gram. Okay. Now, if you measure the angle, right? For example, I say, okay, I have these angles, theta 1, okay, this is theta 1, T1, theta 1, and this is T2, this is theta 2, okay. Now, we select a scale, this is very important, scale, 10 gram equal 1 centimeter on the graph paper. So 95 divided by 10, you will get 9.5. Okay, 9.5 centimeter, and similarly the other one. By the way, you can have the same gram weight or the different, no problem. We'll go by the rule. This is unknown mass from the balance. Okay, بالميزان وزن بالميزان. Right, at the end, first we do our method. Okay, once you finish the, T1, T2, theta 1, theta 2, and T1, T2 in centimeter, okay, then up to here, then we draw our graph. I will show you shortly what we do. And then after that, you have to fill all these tables, right? Right. Now, as I told you, once you finish this experiment and you join this here, you measure this in centimeter, you write down. Okay? For example, I say, okay, I have 9.29 centimeter, right? Okay? Right? And then resultant determinant multiply by 10, I will get 99, right? Okay? Alpha 1, I say, okay, for example, I have 49. You can have different, by the way, so you have to measure. So this is your alpha, okay? All right. And this is how you complete your data sheet. All right. Then second method will be, as we already discussed, this is theta, this is theta, which is equal to theta 2 minus theta 1. You will calculate it here, right? For example, if you have 140, before how much we discussed? Okay. For example, if you have theta 1, how much I told you? 35 and 142. So 142 minus 35. This is just an example, okay? So you will be getting how much? Okay. So 107, for example, you have. Okay? This is theta, for example. This is just an example, okay? And you will be finding this rule I already discussed with you, by the way, so you'll be doing it. Then third method, as I told you, that you will be using the same data. For example, you have from the first one 95 gram, theta 1 you have 35, for example, okay? 142. Now this is the rule, so T1 cosine theta 1. You have T1, you have theta 1, you will find out. Similarly, you have T2 cosine theta 2, T2 theta 2 here. You will get some number here. Similarly, you calculate this one, okay? T1 sine theta 1, and T2 sine theta 2. Once you get all these numbers, is if you get some negative number, don't be scared. So go by the rule. So you add this and this, you will get x component here. And similarly, you add these two, you will get y component of the result. Then as we discussed earlier, right, this resultant is equal to this one, right? And angle like this one. Okay? This is what you will be doing. Right. So, okay, then finally you will find the percentage error. Okay? So this is what you have to fill. Actually, you have information one time, so you will do a little calculation or use the same information. Now, this is the resultant, right? You determine, you calculate. This is your experimental value, okay? Determine, okay? Now, method, first method, graphical method. In gram, for example, you got 9.19 centimeter multiplied by 10, it will be 99 grams. So you can write, for example, 99 grams. The second method, that was the mathematical method. Okay, this is the second method. Where is that? This is second method. What is your result? You will write down there. Okay. And similarly, the third method, your magnitude resultant, you will write down here. Okay. That's it. Okay. And then similarly, you will write down alpha. Alpha in the first method. Okay. In the second and in the third. So you have to. This is the calculation, right? Okay. Now, finally, the percentage error. Okay. So you have three methods. You have the real one with the balance. Please write down M real. For example, what I am doing experiment, I have the real bil mizan on the balance 6.13 gram. Okay, this is from the balance. Okay, all right. So you'll be, this is real minus determined at your experimental result. So you'll be getting some percentage here. So percentage error, method 1, comparing it with the real mass, method 1, what is the percentage error here? Here. The second, third one, here. Okay? Now, you have to write at the end precautions and the sources of error. What is source of, error? Okay? Precautions and sources of errors. When you have different value from the real one, it means you have made some mistake in the experiment, or maybe there is a problem with your tools, equipment, systematic error. So those reasons, those are called the sources of errors in your experiment. All right, you have to discuss with your friends and you have to think. For example, as I told you, if you don't bring the center of the thread in the center of the degree scale, this is one big source of error which will give you a big error in the calculation. And similarly, if the y-axis vertical of the degree scale is not coinciding with the vertical thread of the unknown mass, you'll be having big error. Why? Because you have to take the angles with reference to the zero, x-axis. So if you don't have these adjustments, you will be having big source of error. So you have to look for these precautions. Okay. So that's all about the theory part of your experiment. And thank you very much. And give me 2 minutes. So I'm coming for this.